This research paper, titled Automatic Text Summarization for Research Documents in Sorani Kurdish, is authored by Rondik Hadi Abdulrahman and Hossein Hassani from the University of Kurdistan Hular in the Kurdistan Region of Iraq. It addresses the challenge of extracting concise information from scientific documents, which is crucial for learners, researchers, and practitioners. The paper focuses on automatic text summarization, or ATS, a key application in natural language processing that automates the process of condensing lengthy texts. The study highlights that while ATS methods have been developed for many languages, the Kurdish language, specifically the Sorani dialect, remains underdeveloped due to a lack of resources. To tackle this, the researchers created a new dataset and language model based on 231 scientific papers. These papers were collected from 4 academic departments across 2 universities in the Kurdistan region of Iraq, with each document averaging about 26 pages. In their experiments, they employed 2 main algorithms: sentence weighting and term frequency inverse document frequency, known as TF-IDF. Sentence weighting involves assigning scores to sentences based on their importance, while TF-IDF measures how relevant certain words are within the documents by considering their frequency and rarity across the entire collection. The researchers conducted 2 separate experiments. In the first, they included the conclusions of the papers in the summarization process, resulting in summaries with an average of 5,492 words. In the second experiment, they excluded the conclusions, leading to slightly shorter summaries averaging 5,267 words. These differences allowed them to assess how the inclusion of concluding sections impacts the overall summary quality. To evaluate the results, the team used both automatic and manual methods. Automatically, they applied Rouge metrics, which are standard in summarization tasks. Rouge 1 measures the overlap of individual words, Rouge 2 looks at pairs of words, and Rouge L considers the longest common sequences. The best accuracy they achieved was 19.58%, indicating room for improvement but still a significant step for Kurdish language processing. For manual evaluation, 6 experts reviewed the summaries using 3 specific criteria, such as relevance, coherence, and completeness. The results varied depending on the document, but this human assessment provided valuable insights into the summary's practical usability. The paper's introduction provides essential background on ATS. It explains that ATS has become vital in the digital age, where vast amounts of information are available online. ATS helps distill complex texts, like scientific articles, into shorter versions that capture the key points, saving users time and effort. For instance, it allows researchers to quickly grasp the essence of lengthy papers without reading every detail. ATS techniques are divided into 2 main categories: extractive and abstractive. Extractive summarization works by selecting and combining existing sentences from the original text, while abstractive summarization generates new sentences that convey the main ideas in a more natural way. The paper notes that ATS can handle single documents or multiple sources and even includes query-based models that tailor summaries to specific user questions. Historically, ATS originated in the 1950s and 1960s with early work by researchers like Lunn, who used word frequency to create auto-abstracts. Later, Edmondson improved on this by incorporating factors like keywords and sentence position. In the 1970s and 1980s, artificial intelligence approaches relied on domain-specific rules, but by the 1990s, interest shifted toward more data-driven methods. The paper emphasizes that ATS involves several NLP tasks, such as tokenization, which breaks text into words; stop-word removal, which eliminates common words like the, or, and stemming, which reduces words to their root forms. Over the decades, ATS has evolved from theoretical linguistics to practical applications, driven by the explosion of big data from sources like scientific literature, websites, and news. Machine learning has played a big role in advancing ATS, with models learning to identify important features for generating accurate summaries. However, the effectiveness of these models depends heavily on having suitable training data, which is often limited for less common languages like Kurdish. In the context of this study, the researchers point out that the abundance of textual content online makes ATS essential for filtering and managing information. Despite progress, challenges remain, such as ensuring summaries are naturally fluent and deeply understand unstructured text, which requires ongoing improvements in NLP techniques. This work contributes valuable resources to the field by providing a dataset and models specifically for Sorani Kurdish, helping to advance ATS and related NLP areas. It underscores the need for more language-specific tools to make information accessible in underrepresented languages, ultimately benefiting the global research community.